And it's leg.
Leg.
Thanks. Just for next time, because I know you do the register when they come up. Right. That's all right.
Oh, did I? Sorry.
Right.
Thank you.
Okay, I'm going to do things slightly differently today. Just in order of the order that I do things. You've got in front of you 3 maths papers. Now, for those of you who don't know, your real maths GCSE is 3 maths exams, okay? You come and sit in a hall for an hour and a half each time, and each maths paper is worth 80 marks. And there'll be different topics on each exam, and we won't know what's going to come up on each exam. But what we'll do is after you've done the first exam, that'll narrow things down, and we'll know what's left for the next 2, and that enables us to kind of make some clever guesses and stuff. The 3 exams are really spread out. So if you look at the dates on the front of these paper, these are the 2017 papers. So from summer 2017, so 3 years ago now, this was the GCSE that people actually sat. And you'll notice that the first paper was in like end of May. You then have May half term. You get May half term in the middle of your exams. And actually the other 2 were after May half term in early June, and then the next at the start of the next week in June. Okay, so they were actually, these papers were in 3 separate weeks. So your exam period is over quite a few weeks, quite a number of weeks, and it's just good to know what the format of your GCSE is. So 80 marks from the first paper, 80 marks from the second paper, 80 marks from the third paper, and that gives you a total of 240 available marks. Okay, you guys in here are all doing the higher paper. That means that the lowest grade you can get is a grade 4, and there used to be, back in 2017, and still a little bit of a safety net where you could get a grade 3, okay? But if we don't feel that you're able to get a grade 4 on the high paper, we might look to move you to foundation, where you can get up to a grade 5, because we don't want to risk you not getting that 3 and ending up with a U, okay? You can't get a 1, you can't get a 2, and it's questionable whether they will still keep that safety net of a grade 3, okay? So if you're not on track to get your grade 4, that's when we would look to move you to foundation. But as it stands, all of you in here are aiming for a grade 4, a grade 5, a grade 6, if not higher. And so the higher paper is the right paper for you at this time, okay? What was I going to say? Right, so what is worth bearing in mind, so these are the grade boundaries for the paper that you've got in front of you today. So they add all 3 of your scores together. They don't average them, they get added. So if you do really well on paper 1, and then you do not so well on paper 2, it doesn't matter, they're just going to add your 3 scores together. So you'll notice out of 240, you need 190 marks to get a grade 9, 157 marks to get a grade 8, 124 marks to get a grade 7. So most of you will be able to recognise that on this year's paper, it was about half marks to get a grade 7. Okay, and that's going to seem quite scary, especially if you're sat here thinking, oh, I'm targeted a grade 4 or grade 5. Actually, getting half the paper correct this year got you a grade 7. Well, almost. Okay, so each paper's out of 80. So 40 on each paper, or 41, 42 marks on each paper was a grade 7. 32 marks on each paper out of 80 got you a grade 6. 23 marks on each paper got you a grade 5. 14 marks out of 80 on each paper got you a grade 4. And then this, I think they will remove this by the time you do your GCSE, and it will be a 4 or it will be a U. Okay, so that's the risk, and that's why we kind of make you really prepared and make sure you're ready for the higher paper. So bear that number in mind. When we're going through the papers, bear in mind that if you're aiming for grade 4, and I'm hoping most of you are aiming for this grade 6, so aiming for 32 marks around that level. Now, this isn't concrete, and every year the exams change. So if the exams are a little bit harder, the grade boundaries go down a little bit, and if the exam paper is a little bit easier, then the grade boundaries will go up a little bit, and it will depend how the rest of the country does. So they'll set the grade boundaries after they've marked all of your papers. Does that make sense? So hopefully that now gives you some sort of idea of how many marks you're aiming for. And what I don't want you to all sit here and do today is be overwhelmed and think, oh my word, this is so difficult, okay? Look at the number of marks available and think, do you know what, this is achievable, we've got another year, and we're going to work hard, and that's that. So we're going to start today with paper 1. Paper 1 is a non-calculator paper. You have the first paper, which is non-calculator, and then your second and third, you're allowed the calculator for, okay? So, let me go back to the on here, it's quite quicker. Turn the phone off. Okay, so paper 1, non-calculator. On the last 3 days, it's been impossible to get anyone to talk to me. I've been like, what topic's this? Silence. But I feel like today might be a different problem, because Gabe's here. Right. It's a non-calculator paper. First one's non-calculator. Once you've done that paper, you're allowed to take your calculator into the second two papers. So just bear that in mind when we're doing some calculations today. At various points, you don't need to write this down. At various points, I'm going to put the mark scheme up. Now, the mark scheme I think is quite helpful because it's going to show you what you need to do to get each mark. And sometimes you'll be surprised at what you have to do to get the mark. And hopefully the theme of today, you'll realise, will be to have a go. There are lots and lots of method marks available. So if you get the wrong answer, you still will get some marks for showing your method. So that's really important today, okay? Any M marks are method marks, and P marks are process marks. Now, I examined for Excel, and I'm still not 100% on what the difference between those two is. Method, process, to me it means the same thing. You're showing that you understand the method, you're showing that you know what you should be doing. Maybe you've not got the numbers 100% correct, but they're going to recognise the fact that you know what you're doing. So let's say it's a Pythagoras question, and you do 5 squared add 12 squared, but then you forget and you don't know what to do. They're going to give you a mark for knowing, for starting to know to do the right thing. A is an accuracy mark, so that's only going to be awarded if you use the right numbers. C is a communication mark, so you've managed to explain something maybe in words, like those angles are corresponding. That's going to be a C mark. A B mark is when there's no method needed, so it just means it doesn't matter what you've done. The B mark doesn't need a method. OE means or equivalent. So let's say the mark scheme said that the answer was 0.1 and you wrote 1/10. They're equivalent. The mark scheme would say 0.1 or equivalent, so anything that was equivalent would get you the mark. CAO means correct answer only, so if they've written that, you're only allowed to write what they've written, and if you've written anything different, they're not going to allow you mark. FT is follow through. So have you ever seen a maths question where there'll be a part A and a part B, and part A just looks horrendous and you think, I've got no idea what I'm doing. And you think, oh, part B, I could probably have a go at that. That's why the follow through comes in. If you make a complete mess of part A and you get it completely wrong, quite often part B will have follow through marks where they'll say, it doesn't matter what you did up there. We're going to look at that and award you the marks on part B depending on what you did at the top, okay? SC is special case, just because there's always those questions that are a bit random and don't fall into any category. Debt is dependent, so sometimes you're working, if you've not shown the step before, they won't give you the next mark. Independent is the opposite, so it doesn't matter if whatever you've done before. AWRT is answer which rounds to, and ISW is ignore subsequent working. So if you had a fraction question and they didn't ask you to simplify it, and you did simplify it, but you simplified it wrong, it might say ignore subsequent working. So if you've gone on and carried on, you had the right answer and then you carried it on and went wrong, it would say don't worry about it, ignore the subsequent working, and then just award them the right answer if you can see it. Okay, so these are all here to kind of make sure that examiners give you all the same marks and keep it nice and fair. Okay, question number 1. So with today, it'd be really good if you can just write down anything I say that you think, oh yeah, that's helpful, that'll help me remember. When we get to the end, I'm not going to do the full papers, okay? I'm going to try and do the first 9, 10, 11 questions, maybe a little bit more of each paper. That should be enough to confidently get you up to maybe a grade 5, grade 6. And hopefully at this point, given that it's a year to your GCSEs, put you in feeling quite confident about what we've got to go. Okay, write down everything I say, write down the answers. This should be kind of exemplary work. And yeah, please put your hand up and ask me. I know it's a bit scary because through the hall there's lots of people, but if you're not sure of anything, it's a really, really good idea just to get that help. Okay, first question. The scatter graph shows the maximum temperature and the number of hours of sunshine in 14 British towns on one day. So we've got the maximum temperature on our y-axis, and we've got the number of hours of sunshine on our x-axis. It says one of the points is an outlier. Write down the coordinates of this point. Last year in the exam, you were asked to write down what is an outlier. So you might find it helpful to write this down. An outlier is a value which does not fit the trend of the data. An outlier is a value which does not fit the trend of the data. So there's a pattern to the data, and our outlier doesn't look like it fits. Hopefully from that description, you can see that this point up here is our outlier. In science, they sometimes call it an anomaly as well. That point there is our outlier. Remember, for coordinates, we're going along the corridor, up the stairs, and that's our first mark. On Hegarty, don't forget that coordinates, you have to put the brackets around or else you get it wrong. They put the brackets there for us though, which is nice. Okay, and then it says, for all the other points, write down the type of correlation. We've done scatter graphs this year. This should be nice and straightforward to you. If it's going up, it's positive. If it's coming down, it's negative. This is very clearly going up, so we're just going to write the word positive on that line. They've not asked us for the strength. If they said, write the strength and the correlation, then we'd have to write strong positive or weak positive. It's a 1 mark question. They just want to know the correlation. If we write positive or negative, or in this case positive, that's going to be sufficient. The other thing they might ask you on a scatter graph is for the relationship. Now, if they ask you for relationships, we all know that relationships are a little bit more complicated. So we need to say a little bit more, okay? So a relationship would require you to say something like, the more hours of sunshine, the warmer it is on that day. Okay, so you're actually describing what's happening with the 2 axes. So if they ever ask you for the relationship, describe what's happening. The closer you live to town, the more expensive the rent is, or I don't know, the warmer it is, the more sales of ice cream. That's a relationship. You're talking about what's actually happening. If it's correlation, 1 mark answer, you're just going to write positive. 2 marks. Yay! Okay, next question says, on the same day in another British town, the maximum temperature was 16.4. Estimate the number of hours. Now, what a lot of you are guilty of doing is going, oh, 16.4 for the maximum temperature, that's about, we're going to go 1, 2, 3, 4. Okay, first error. Look carefully at the scale. You can't just go 16 and count up 4 squares. It goes 16, 18, so this would be 17 here. If you find it helpful, write in 17 there. 16.4 is only going to be 2 squares up, yeah? And we could just go, oh yeah, be around here somewhere. Not accurate enough, okay? You must, every single time you see a scatter graph, draw a line of best fit. At some point, they're going to ask you to estimate and read off the graph, and we can't read off the scatter graph unless you've drawn a line of best fit. It should look something like that. Draw your line of best fit. Should have the same number of points. You see there's 1, 2, 3, 4, 5 below, 1, 2, 3, 4, 5 above. If you took the points away, the line should really clearly show where those points were. Am I doing all right? Am I walking? Am I walking that shot like a... Oh, green. The line of best fit should really clearly show. If you took the points away, where were the points? Go across at 16.4. Hit the graph, go down, and you allowed anything for this answer between 12 and 13. I think if you'd have guessed, it would have been easy to write like 13.1 or whatever. So line of best fit, always a line of best fit. Notice that one of those marks was a method mark, M1. So they expect to see this, and that's your first mark. Your second mark is for an answer 12 to 13. Four marks. It's all right, isn't it? Okay, then it says, a weatherman says, Weatherman says, temperatures are higher on days when there is more sunshine. Does the scatter graph support what the weatherman says? Give a reason for your answer. So if you just write yes, sorry, you're not going to get a mark because we must give a reason for our answer. I'd say yeah, it does, doesn't it? Yeah. The majority of points for high temperature appear when there are more hours of sunshine. There is a positive correlation. Okay? Yes, because this is probably actually asking you more for the relationship, isn't it? Yes, because as the temperature goes up, there are more hours of sunshine. Something like that. So if you remember back to the grade boundaries, yeah, 4 on this paper, you need about 14 marks. We've already got 5. Okay, so very achievable. Just need to make sure with these topics at the beginning that we know how to get full marks and feel really confident on these grade 4 topics, okay? Last year, no, year before, can't remember. Couple of years, within the last couple of years, there was a scatter graph question. And the scatter graph question said, it was about runners, it was about a 100-metre sprint. And there was a 15-year-old, an 11-year-old, and they did it in like, I don't know, 20 seconds. And there was a 12-year-old, they did it a bit quicker. 13-year-olds did it quicker. And you ended up with a scatter graph that came down and had negative correlation. And then the question at the end, because examples are a bit predictable, they don't change up the questions much every year. You can do really well on one paper, you can do really well on all the papers, to be honest. There was a question like this, but it said there's a 20-year-old and he's going to run the race and he can do it. He says he looked at the graph and he can do it in 8 seconds. Now, most of you know Usain Bolt's time isn't even that quick, okay? What we've done is just like gone with the graph and like tried to make a point up here, or well, on that one it was coming down, and so it was like way off the bottom. It's really, really dangerous, and they will sometimes ask you to do it on an exam and expect you to know. We cannot draw conclusions about any data that is beyond the data that we have. It's called extrapolation, okay? So if I was trying to say, they might have put a question on this year, to be honest, saying the temperature one day is 5 degrees. How many hours of sunshine were there? And you'd be like, some people would try and follow it down, or 10, you can't even do it here. We've only got data between here. So it's okay to draw a line of estimate and do that, but if they ever ask you for anything beyond the data that you've got, you say we haven't got any data to support that, we can only make conclusions about between the data that we've got. Does that make sense? Yeah? No? Okay, lovely. Right. Good. Any questions on that one? 5 marks. Not a bad first question, it's okay. Good. Question number 2. Express 56 as the product of its prime factors. So most of you will remember this to be the tree thing. Okay? Here are your prime numbers. For my class, they're the football numbers on the top of my whiteboard. 2, 3, 5, 7, 11, 13, 17, 19. Obviously, they go on forever and ever and ever. But it's definitely helpful to be really familiar with the first ones. And then product in maths means multiply. So if you ever ask for the product of something, it means a multiplication, and that's going to help us. So write 56 as a multiplication of its prime factors. Okay. So we're going to start with 56 at the top and do 2 numbers that times together to make 56. I went for 28 and 2. You might have gone for 7 and 8. It doesn't make a difference. When you get to a prime number, you circle it, and if the number isn't primed, you carry on. So 2 is a prime number, we circled it. 28 isn't. It's 2 times 14. 2 is prime, so circle it. 14 isn't, and that splits to be 2 and 7. You might have done 7 times 8, circle the 7. 8 is 4 times 2, circle the 2. 4 is 2 times 2, but you'll get the same answer. You'll still get 2, a 2, a 2, a 7. Now, at the minute, I've got 1 mark, because I've not actually written my answer. And the product bit was the clue. Sometimes it's also called the prime factorisation. Most common mistake I see, and you guys are guilty of it because you had this on your exam back in, I can't remember, whenever you did it, October, whenever it was. And I saw this on quite a lot of your papers, okay? We had a prime factorisation question, and we did this. That's the most common mistake. Don't do that. You need to write it with multiplications in between. So 2 times 2 times 2 times 7. You absolutely can write 2 cubed times 7. You would have to write that on Haggerty. I think there's a couple of questions where they say, give your answer in index form. And index form means with the indices, the powers. But if they don't say that, don't worry too much about it. We're not going to lose any marks for just writing 2 times 2 times 2 times 7, unless they say, give your answer in index form. And then we have to write 2 cubed times 7 because we are able to do it in indices. Any questions on that one?
That one's quite a good one if it's on the calculator paper, isn't it? Because you can use your calculator.
There's a button on the calculator, yeah, you're right, sir. It's shift something, I can't remember what button it is.
Fact.
Yeah, but the fact is yellow, but what's on the button?
It's, it says fact, so shift fact. It's got commas on the button.
Oh yeah, you're right, it has.
And basically you have to put the number in first, so you go 56 equals, so the number's there, and then you go shift facts, and you get the prime factors.
Yeah.
But this is not calculated.
Yeah.
But sometimes you using that to calculate highest common factor,
Lowest
common multiple, and then if it's on the calculator paper, then you use your calculator to do that.
Any questions on that one? Okay, so we're up to 7 marks now. Okay, we're up to 7 marks out of 80. Okay, question number 3 is a multiplication. Now, I'm going to get you to have a go at this with a multiplication method of your choice. So though my class will probably know I quite like the lattice method with the diagonal squares, you might prefer the column method. I'm going to ask you to have a go using whatever method you want right now, and then I'm going to put up both the column method and the lattice method, and you can see which one you prefer, which one works best for you. But have a go first. Let's see if you've got a method, if you can do it. I'll just give you a few minutes. Really, you should be spending, there's 80 marks, and there's 90 minutes. So if you think in your head, all right, 3 mark question, I can spend 3 minutes on this. That's always a good guide in the exam. Have a go. If you're doing column, I would take the decimal points out. Just do 546 times 43 and then put it back in after. If you're doing lattice, remember it's 3 squares across, 2 squares down. You start there thinking, I don't have a method. Don't worry, I'll do it in a minute. Who wishes they have their calculator? This is such an easy one to practice at home. You can just say to your parents, give me 2 numbers. And then you can times it, and then you can just check it on your calculator if you've got it right or wrong. Such an easy one to practice at home. And again, I think times tables helps with this as well. Okay, so if you've done the column method, hopefully it looks a little bit like that. You're doing 3 times 6, which is 18. So start here, 3 times 6 is 18, carry the 1. 3 times 4 is 12, other one is 13, carry the 1. 3 times 5 is 15, other one is 16. So you've dealt with the 3, you then go on to the next row, put your 0 in, do 4 times 6, which is 24, 4 carry the 2. 4 times 4 is 16, add the 2 is 18, and 4 times 5 is 20, other one is 21. Adding those together gives you 2, 3, 4, 7, 8. Okay, and then we've got to work out where to put the decimal point back in. So when we're multiplying, the number of decimal places in the question, so the number of numbers after the decimal point, is the same as in the answer. So if there are 2 numbers here after the decimal point, then there's going to be 2 numbers here after the decimal point. So it's going to be 234.78. Also, use your skills of being able to estimate. This is 50. We're doing one significant figure. This is 4. And 50 times 4 is 200. So we would expect our answer to be somewhere close to 200. So 234.78, given that we rounded that one down and we rounded that one down, that makes sense. Okay? So 234.78. Now, I personally prefer this method if you're not confident with that one. Okay, when I mark GCSE papers, and I marked a question like this, and I must have marked thousands of them, this goes wrong less often. And I think it's because of these little numbers, because of the carrying. Now, if you're super confident with this, and you've been doing that for as long as you can remember, and you're absolutely certain that doing that is the right method for you, absolutely fine. If you're not sure, if you're sat here and you're thinking, I'm not sure what method I should be using, I'd probably lean towards this one, just because I see it go wrong less often. So I think this one's easier, personally, okay? The hardest thing about this one is drawing the grid. So, how many numbers are in this number? We've got the 5, 4, 6, how many digits? So we've got 5, 4, 6. So I've done 3 boxes going across. And then this one's got 2 digits. So I've got 2 boxes going down. So it's a 3 by 2 grid. You draw the boxes, and then each section, you're going to split it from the top right corner to the bottom left. So this square gets split diagonally, this square gets split diagonally, this square gets split diagonally, this one, and this one. And then I've just made them a little bit longer, so I've got somewhere to put my answer. Okay, that's probably the hardest bit on that one, is drawing the grid. And again, if you're practicing this at home, if you're just saying to your parents, give me 2 numbers, then you can practice that, okay? To fill this out, each square here is going to be the number at the top multiplied by the number at the side. We're going to put the tens on one side and the units on the other. So 6 times 4 is 24. So you're going to put the 2 and the 4. 4 times 4 is 16, so 1 6. 5 times 4 is 20, so 2 0. 5 times 3 is 15, so 1 5, and so on. So it's going to look like that. Okay, so you're just filling out each little square with the number top and number side. So far, we haven't had to do any carrying, which is quite good because it's not going to be as messy. And then all we're going to do now is add down the diagonal columns. So we've got one diagonal column here, another diagonal column here, another diagonal column here, and here, and here. So the first diagonal column is just an 8. Just going to write 8 here. Then 4 add 1 add 2 is 7, so 7 goes here. 2 add 6 add 1 add 5 is 14. Now with 14, we can't put 14, so we're going to put 4 and carry 1. 1 add 1 is 3, and 2 is 2. So the answer, we're still getting the same digits, 2, 3, 4, 7, 8. I personally think it's just a little bit clearer. Less carrying, you're going to be less likely to make mistakes. The beautiful thing about this method is that then, where the decimal points are, you go down with this decimal point, and across with this decimal point, and wherever they meet, which is going to be here in this case, we go down that diagonal pathway, and that tells you where to put your decimal point as well. Okay, so for decimals, again, it's just a little bit of an easier method. We can do it the same way and think, oh, there's 2 numbers after decimal point in the question, so it'd be the same in the answer. But yeah, I don't care which one you use, just be confident with one of them. Okay, mark scheme refers to 3 methods. So for the mark scheme, you've got your column method, you've got your Napier-Bones lattice method, the one I just showed you, and then you've got this, the grid method. Now, I think they teach you this at the end of primary school, and I don't love it. When people get to the addition bit, where they add up all the separate bits, sometimes they line it up wrong, and again, there's a lot of carrying, there's a lot of addition to worry about. I think that doing 20,000 add 1,600 add 240 add 1,500 add 120 add 18 is harder than laying it out like this, personally. But just because of how many times I've seen it go wrong. So I think I would rather we were confident with one of these 2 methods, just because I think you're more likely to get full marks. Just pick one, whichever one you prefer, it doesn't matter which one it is. Okay, your first mark was having a method and starting and doing it right somehow. Okay, your second mark was for the right digit, so 2, 3, 4, 7, 8. Even if you put the decimal point in the wrong place, if you've got those digits, that's your second mark. Third mark was for having the right answer with the decimal point in the right place. Okay, so if you started and you went wrong somewhere, you're going to be limited to 1 mark. Okay? So be really confident on that, because that's 3 marks. We're up to 10 marks now for GCSE. We said 14 marks on this paper was a grade 4. We're up to 10 marks, just question 1, 2, and 3. Okay. Right. Question number 4. Was everyone done on that one? Do you need anything else to copy down when we go? You're not going to tell me anything. Lucy, we good? It's normally Lucy. Okay, question number 4. The area of the square ABCD is 10 centimetres squared. Show that x squared add 6x equals 1. Now, I'm not going to be surprised if most of you are sat there going, What? Where on earth have they got that from? Okay, and that always happens with show that questions. So on a show that question, it's going to seem like the thing they're saying, show that this has just come from absolute nowhere. I want you to ignore that entirely. We're just going to do something and hope that we get the same. So they're talking about the area of this. Okay, they're talking about the area of this, and they're saying that the area equals 10. So let's work out the area ourselves. We'll do it. We'll say that that equals 10, and then just see where we get to. Okay? So ignore that completely for now. Let's just do the area of this, and now get 10. Now they've even split it into 4 little sections for us. Can anyone tell me the area of any of these sections? Be brave. Any of you? What would this section be? What would the area of that bit be? Shout out if you know. Or don't. Not quite 12. What's the width? What's the height? 3 times 3? So good. Yeah, this bit's got an area of 9, yeah? What about this bit? This is x wide and 3 tall. This bit's going to have an area of not be. Do we know that that's 2? Yeah, it's going to be 3x, isn't it? Because it's x. We don't know what it is. So this bit's going to be 3x. What about this bit down here? We've got a height of x and a width of 3. That bit's going to be 3x as well. What about this square? We've got x for the height and x for the width. Very, very good. Well done. So hopefully that makes sense. We're doing the area. They said in the question, we're working out the area. So write down the area for each bit. The area has 9, 3x, x squared. That is the area. And we can collect together our like terms. That can't be all of them. Okay, we don't know what x is. They've not told us. We're not going to ask to solve it either, so we're not even going to work it out. Which of those are like terms? Which ones can I put together? Good, 3x and 3x, they're like terms, well done. So I've got x squared, add 6x, add 9, haven't I? That's my expression for the area. And they told us that the area equals 10. So I'm going to write this. X squared, add 6x, add 9. That's what we think the area is. And we know that that has to equal 10. Now that's starting to look like this. But what do we need to do? I've got the x squared, that's good, that's what I want. I've got the 6x, that's good, that's what I want. But that 9, I don't want that 9 to be there. How can I get rid of that 9? What's the opposite of add 9? Take away 9. And if I do it to one side of the equation, good, I've got to do it to the other. So I'm going to take this 9 away, and take 9 away from there, and then I've got the answer, and that's it. It only came to that, really, at the very end. But they were talking about the area, so we worked out the area of some bits, and that's another 3 marks. I think the show that questions are really hard. It seems like it's just coming from nowhere. Again, you just want to do some stuff and see where you get to. If ever they give you the answer, I feel like I've said this on my blog so many times. If ever they give you the answer to something, do it and then say that it equals that number. So they said the area is 10. So we did the area, we worked it out, and we said it equals 10. The other way of doing that would be to say that this side is x add 3, and this side is x add 3. And so x add 3, which is the width, times x add 3, which is the height, equals 10. And if you'd have expanded that out, x times x times 3, 3 times x, 3 times 3, you'd have got that, and then it would have been the same. So you could have done it that way if that makes more sense. Personally, I think seeing the 4 little sections made more sense to me. But everyone's different. Okay, question number 5. 5 mark question. What are we up to now? Lost count. 13. So is this 18 now? Yeah. Okay, this rectangular frame is made from 5 straight pieces of metal. The weight of the metal is 1.5 kilograms per meter. Work out the total weight of the metal in the frame. So it's a frame. Okay, you could stick your arm through there. It's not filled in. You can stick your arm through there. It's just 1, 2, 3, 4, 5 straight pieces of metal. Okay. I know that the top bit would be 12, and I know that that bit would be 5 because it's a rectangle, but I don't know the length of that. So that's going to be the first thing that I'm going to try and work out. Can anyone tell me what topic? Come on, I'm confident here. Someone's going to tell me. What topic can we use to get the length of that diagonal bit? We've got a right angled triangle. What topic could we use? Anyone? No? Yes. Which is what? Beginning with P. Perfect. Thank you, Sean. Made my day. Pythagoras, okay? If you've got a right angled triangle and you want the length of the longest one, loads of you are sat there going, yeah, I knew that was the thing. If you want the length of the diagonal, the longest bit, you can do Pythagoras. We'll do 5 squared add 12 squared, and whatever we get, we square root our answer. Okay, 5 squared add 12 squared is 169. What's your favourite question, sir? What's square root of 169?
It's a Pythagorean triple.
It is, sir. A Pythagorean triple is when all 3 numbers in Pythagoras are whole numbers. Sometimes you square root and it makes a decimal, that's not a Pythagorean triple. So 3, 4, and 5 is another one. If you do 3 squared add 4 squared, you get 25. Square root of 25 is 5. That's another Pythagorean triple.
Builders use it
Yeah.
quite a lot.
Construction.
3, 4, 5.
Yeah, right.
It's familiarity. I started teaching maths 7, 8 years ago. And when those questions came up to start with, I didn't spot that straight away, and I would work it out. But the more you see these past paper questions, the more you'll spot that kind of thing. So you'll see, well, 5, 12, I know that's 13. But it's just about practicing these type of questions and seeing that. That experience means you'll spot that type of thing. But at the same time, you can obviously work out, it's really important that you know your square numbers.
Mm. Yeah, up to like 15, I'd say. I quite like, so 13 squared is 169, 14 squared is 196. I think those two are quite easy to remember. And then 15 squared is 225. I'd say they're on my pillar in my room as well. I think if you know up to 15 squared is 225, that's going to be good for the non-calculated paper. 12 squared out 5 squared. Yeah, same as that. If I see a right angled triangle and it's 3 and 4, I know that that hypotenuse is 5 without even having to work it out. It's just familiarity. 3, 4, 5, 5, 12, and 13 will always be your hypotenuse. Okay? Hypotenuse is the name for the longest side. So now we know we've got 5, 5, 12, 12, we've got 13. So the total length of the metal, of all of the metal that's making this shape, is 5 add 5 add 12 add 12 add 13, which is 47. And it says that the weight of the metal is 1.5 kilograms per meter. So we're going to do 47 times by 1.5. And again, some of you might be thinking, I wouldn't know how to times it by 1.5. That's absolutely fine. That's why we have the lattice method or the column method. You could just do 47 times 15 and then put the decimal point back in the right place. Okay? The lattice method for that one would be 2 squares wide and 2 squares tall. 47 times 1.5. Or you could just say, well, timesing by 1.5 is the same as doing 1 lot of 47, which is 47, and half a lot of 47, which is 23.5, and then adding that together. So your answer is 70.5, and that's a 5-mark question. Now I want to show you the mark scheme for this one. So your answer is 70.5, and you've got 5 marks available, okay? You get 1 mark, this is what I said to you at the beginning, if you write 5 squared add 12 squared. So you can't remember what you have to do from there, but you know it's Pythagoras, and you know you have to do just 5 squared add 12 squared. Second mark is for getting 13, but you might, no, well, hang on, for Pythagoras I need to do 5 squared add 12 squared, and then I need to square root it, but I don't know what the square root of 169 is, and I haven't got my calculator. So if you wrote the square root of 169, that's still going to get you 2 marks. Your third mark is for adding everything together. So let's say you thought the square root of 169 was 11. You just got it wrong on the day. Don't remember. and you had 11 here, you're still going to get that third mark. It's a process mark. It's P. Okay, it's not an accuracy mark. It's for doing the right process. You have to have got a mark from here, at least one mark from here. But if you've added together 5 add 5 add 12 add 12, add whatever number you've got from here, that's going to get you your third mark. Your fourth mark is for multiplying at least 2 lengths by 1.5. So let's say you had no idea about Pythagoras, you just completely forgot about it. You can still get this mark. They told you in the question that to get the weight, you had to times by 1.5. So if you just took the 5 and the 12 and you times that by 1.5, you can still get that mark. And then your fifth mark is the correct answer only. So for 5 marks, you've got to have the right answer. On the answer, it's got to be 70.5. But hopefully you can see that there are 4 marks up for grabs there. Even if you've got the wrong answer, you can still get up to 4 out of 5, which I think is fairly generous for doing the right thing. So this is why we say to you in maths, don't leave questions blank, have a go. You never know, you might have gained a mark or 2 just by having a go. Don't be put off. Any questions on that one?
If you've got those first 5 questions correct, you're on 18 marks.
Yeah.
If you get 18 marks on those 3 papers, then you've got a total of 54. You're well inside 4.
Yeah. Hopefully that makes some of you feel a bit more confident about the scary maths paper. I think the hard thing with doing the higher paper and getting grades 4, 5, 6 is that most of the paper is going to be terrifying, a little bit difficult. But it's about having the confidence and going in and saying, do you know what, I'm going to look at the first 10 questions and I'm going to really ace those questions and spend all my time on those and confidently get the grade I need. Okay, question number 6. Please write this down. This should be so familiar to you now. We've done this year quite a lot. The equation of a straight line on the graph is y equals mx plus c, where m is the gradient and c is the y-intercept. And hopefully you've done this on Hegarty as well, where you have to write what m is, write what c is, write what m is, write what c is. There's a Hegarty task on that. I'll give you the numbers for all the Hegarty tasks at the end. So y equals mx plus c is the equation of a line. And it's really helpful because we can tell what the gradient is straight away just by looking for this number, and we can tell where it crosses the y-axis straight away just by looking at this number. But it has to be the y on its own and everything else on the other side. So this top line here, the equation of line L1 is y equals 3x minus 2. We like this line. This line is nice. We can see immediately that this line has a steepness of 3, gradient of 3, and a y-axis is going to cross at minus 2. So if you imagine your axis, it's crossing down here at minus 2, and it's going up in 3. Okay, so we can immediately tell what's going on with this line. The equation of the line L2 is 3y minus 9x add 5 is 0. Horrible. Okay, I can't tell anything about this line because it's not in this format. The y isn't on its own, and it's got loads of other stuff. It's just a bit of a mess, this one. It's still a straight line. It's got no powers. Okay, it's still a straight line. If it had powers, it might be a quadratic or a cubic. It might move, it will bend on the graph, whereas these are straight lines because they've got no powers. Show that these 2 lines are parallel. Now, to show that 2 lines are parallel, like that, they're going to have the same steepness or the same, beginning with G. No, just me. Okay, fine. I'm going to stop asking. Gradient. Okay, they're going to have the same gradient. They'll go up by the same amount. If they're parallel, they're never, ever, ever going to meet. They need to have the same gradient. We know what the gradient of our top line is. The gradient of our top line is 3. So we now need to show that the gradient of this line is 3 as well. To show that 2 lines are parallel, you need to show that they have the same gradient. So we're going to switch up the bottom one. This bottom equation here, we need to get this on the other side, this on the other side, and then we can divide by 3 so that the y is on its own. We need to get the y on its own. So first thing I'm going to do, I'm going to take that second line, I'm going to add 9x to both sides to get rid of this. Goes over here. And I'm going to take the 5 away, and then I've got to take 5 away from this side. So I started with 0 on the right-hand side. I've added 9x to both sides to get rid of this. Well, I'll add 9x here as well. And I've taken away 5, so I've got to take away 5 from here as well. So 3y equals 9x minus 5. All I've done is add 9x to both sides, take away 5 from both sides. I'm trying to get that y on its own. Sometimes I do a dotted line down here in my class, you know. just to help you receive what, like the left-hand side of the equation and the right-hand side of the equation. Feel free to do that if you want. But now I've got 3y, I'm not there yet. I still need to get the y on its own. 3y means 3 lots of y. What's the opposite of times in by 3? We need to divide by 3. So I'm going to divide the left-hand side by 3 and divide the right-hand side by 3. Now, normally, you just go all divided by 3. Just turn it into a big fraction, say all divided by 3. But because I'm interested in the two terms individually, I want to know what that bit is and I want to know what that is. I'm actually just going to do that divided by 3, that divided by 3, that divided by 3. So I've done it in 3 individual bits, and that's okay, it doesn't make any difference. So I've done that divided by 3 is y, 9x divided by 3 is 3x, and 5 divided by 3, we love this in maths, it's just a little trick. I don't want to do 5 divided by 3, so I'm just going to write a little fraction. Just say it's divided by 3 and put it on the bottom. And now, hopefully you can see that this line also has a gradient of 3. The number in front of the x is also 3. So there's both my lines, and we're going to write something along the lines of both lines have a gradient of 3, therefore they are parallel. Done. In maths you can do 3 dots for therefore if you want, because we're lazy people, we don't like writing words. It's just dot, 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 3 little dots means therefore. Didn't say that yesterday, should say that. I think that's quite hard if you're not confident with changing the subject to a formula or solving equations. So if that bit was confusing you, maybe look at changing the subject to the formula or solving equations. That's going to help you with that still. But again, I'll give you the HC numbers at the end. Any questions on that one?
Well worth getting a post-it at home with y equals mx plus c up in the room, with gradient and y-intercept there, having that more really helpful.
Sometimes they trick you, they do it the other way around. So the equation, it might be y equals 7 add 2x, and you still have to know that it's the number with the x that's the gradient. Sometimes they try and trick you. The number on its own, that's your y-intercept. The number with the x, that's the gradient. Cool. Number 7? Oh. First mark for starting to do stuff. So even if you only got to 3y equals, even if you only got to 3y equals 9x minus 5, then you're still going to get a mark. Second mark for showing that they're both the same. Right, question 7. There are 10 boys and 20 girls in a class. How many people in the class? Yay, 30. Who's that? Thank you. The class has a test. The mean mark for all the class is 60, and the mean mark for the girls is 54. Work out the mean mark for the boys. Now, we only know one thing about the mean. There's only one sum you know, and you've probably had it drilled into your head since primary school. For the mean, we add it all up and divide by how many there are. That's the only thing we know about the mean. There's no, like, sum that you don't know, that's it. That's how you work out the mean. You add it all up and you divide it by how many there are. But they've given us the answer. So they've already added up all the children's scores, divided it by how many there are, and they've got 60. And for the girls, they added up all the girls' scores, divided it by how many there were, and got 54. So when you're given the mean, all you can do is work backwards. What's the opposite of dividing by how many there are? Times it by how many there are. Perfect. So all I'm going to do is take the mean and times it by how many there are. Okay? The total student score divided by 30 made 60, and the total girls score divided by 20 made 54. So they already did that for us. All we can do is go backwards. Okay? I'm going to do 30 times 60. So there are 30 children altogether, and the mean was 60. So 30 times 60 is 1,800. So that must have been all their scores added up. Because otherwise, when they divided by 30, they wouldn't have got 60. So we can go backwards. Multiply by 30 to get all of their scores all together. That must be what it is added up. And then same with the girls, there are 20 girls. So if we do 54 times 20, we get 1,080. Just times it by 2 and then times it by 10 if you want to times it by 20, so that'll be easy. If the girls got 1,080 and all of the students altogether got 1,800, hopefully we can see how many points the boys must have got between them. If this is all of the girls and the boys' scores added together, and this is just what the girls got, then the boys must have got 720 points between them. How many boys were there? 10. Good. So the mean for the boys is going to be 72. It's a non-calculator paper, so they're nice to you. They only make you divide by 10. So you've got to multiply. When they give you the mean, you've got to multiply by how many people there are. You can only go backwards. That's all you can do.
That question's got that mean, isn't it? Astro.
Very good. Did you have your okay, I'm supposed to point that. Your numbers okay. Well, I'll give you an example of another question that came up like that in previous years. Instead of giving you the total, they told you like all the boys. So let's say there were 10 boys and on average they got a score of 50. And there were 30 girls and on average they got a score of 60. What the most common mistake I see is people just add those scores together and divide by 2 to get the average for the class. But if there's more girls than boys, it doesn't work like that. So you've got to do the number of girls times by the mean girls score, the number of boys times by the mean boys score, add that together and divide by the total number of children. So whenever they give you the mean, you're always going to multiply by how many people there were to get the total. That is all you can do. Just got to go backwards. Okay? Okay? Yeah, good. Lovely. Okay, standard form, which again, you've done this year. Write 7.97 times 10 to the power of minus 6 as an ordinary number. Now, hopefully we're remembering that a minus power makes the number really, really, really small, and a positive power makes the number really, really, really big. So this is going to be a decimal number. We need to divide by 10, 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 6 times. So you can, if you want, get your decimal point and just bounce it. 1, 2, 3, 4, 5, 6, and then fill in the zeros. Now, with a negative power, actually the number of zeros is always the same as the number. So your answer for this one is going to be 0.000000797. There are 6 zeros there. Doesn't work like that for positive integers. Is that me or you or someone else? Someone. If I gave you 7.97 times 10 to the power of 6, it's going to take you 2 jumps to get 797. So you've then got 4 more jumps to go. So there'd actually only be 4 zeros if it was positive 6. It would be 797,000. 7,970,000. So you can't just do 6 zeros, but you can if it's negative. Okay? Easy mark. Just being confident with your standard form, knowing which way it's going, knowing how many zeros it's got. Most common mistake, people would be a couple of zeros out or have gone the wrong way. So just be really clear that a negative power is going to be a really small number and a positive power is going to be a really big number, and count carefully. Now, if you divided that by 10, you'd get 0.797. You divided it again, you'd get 0.0797. So just take it slowly and make sure you get the right number of zeros. Okay, question B, work out the value of 2.52 times 10 to the power of 5, well that's 252,000, divided by 4 times 10 to the power of minus 3, which we know would have 3 zeros, so 0.004. Now, when we divide numbers, the digits don't change, okay? The digits don't change. So if I had 100 divided by 4, that's 25. If I did 10 divided by 4, that's 2.5. If I did 1,000 divided by 4, it's 250. And you still get that 2 and a 5 no matter what. So all I'm going to do to answer this question, I really don't want to do 252,000 divided by 0.004. Okay, I'm not very good at dividing by decimals when it comes to really big numbers. What I'm actually going to do is I'm just going to do 2.52 divided by 4 to get the digits. Okay, so we're going to bus stop method that. Bus stop method, remember how many 4s go into 2? Well, none. Carry the 2 over. How many 4s go into 25? There are 6. Carry the 1. How many 4s go into 12? 3 times. So I've got my digits. So I know that there's going to be a 6 and a 3 in the answer. But now I just need to work out how many zeros it needs. Now we're doing 10 to the power of 5 divided by 10 to the power of minus 3. What do we do with the powers when we divide? What do we do with the powers when we divide? We take them away. Okay? So I'm going to do 10 to the power of 5 divided by 10 to the power of minus 3. Now the reason it's 8 is because we're doing 5 minus minus 3. And 5 minus minus 3 makes a plus, so that's why it's 10 to the power of 8. You might want to write that there. 5 minus minus 3 equals 5 add 3, which is 8. And it makes sense. If you think about trying to fit 0.004 into 252,000, loads of them are going to fit in. Way more than 252,000. So it's going to be a really, really, really big number. And so that's what I've got so far. But that's only going to get me 1 mark, sadly. Why is that not going to get me both marks? What is wrong with that? You can pick one. Roman, why is that not going to get me full marks? What's wrong with that? Why is that not in standard form? Go on, Sean. Not brackets. Good guess though. What does a number have to be in standard form? Yeah. Oh. Who? Oh, yeah. Sorry. Yeah, good. So it needs to be between 1 and 10. Well done. It's not in standard form unless that number is between 1 and 10. Okay, so we need to make that 6.3. And if we make that 6.3, we've made that bit 10 times bigger. So we need to make this bit 10 times smaller. So it's going to be 6.3 times 10 to the power 7. Sorry, Brennan. I'll stop there. How many marks is that now? 21? I haven't been paying attention. We haven't the last one. Oh no, we didn't have those, so what's that? 24 now. So that's a grade 5 now. I think. Yeah, so that's you've now if you've got all of those marks so far, you've got a grade 5. Okay. Yeah, 10 o'clock. Right. We'll carry on with this. We're going to give you a 15-minute break. Okay, so we're doing an hour, which we've done. 15-minute break, an hour,